Otherwise,
Okay.
yeah. Okay. So it's going to be some things in group actions, but yeah, I'll try to answer some questions.
There is a there is a group of order 108,
Okay,
and we have to show that it contains a normal subgroup.
right. Show and G contains non-trivial normal subgroup. That's it.
Yes, yes.
Okay. So let us see. 108 will factorize right. It's 2 square into 3 cube. Right. Yeah, so there can be many groups of order 108, but we want to show them all of them have a non-trivial normal subgroup. I can try to use silo theorems. Have you done silo theorems?
Yes, I've done, but if you and say again, it will be
Yes,
better.
yes, yeah. Even I have to see and I have to say and I have to also maybe see. I don't remember all that. But we have to be open to using everything. Otherwise, I don't.
Should we do one previous questions like uh, prove that the silo P subgroups are in the form of GPG inverse, where P is the silo sub P subgroup,
Okay,
something like that.
but yeah, let's assume that and do. Then we will see.
Okay.
So this is not certainly not just as a group action. I just call it problem in group theory. So first, let me just think if I can say something without silo theory. Then we will come there. Yeah, if I can just think in terms of group actions and say something. Let me see. Let's try. So by silo, there exists H okay, and I will try to prove that this one is normal. So let us try to count how many silo 3 how many silo 3 subgroups are there? Yeah, you will see why I'm trying to do this if you know the three results and just the last conjugate one you said. So from there it makes sense why I'm trying to do this. So let's call this number n3. Okay, then again you know by silo is another silo theorem, and all these is proved using group actions, which is a separate topic. I mean, proving the silo theorem should not be mixed with doing the problems as applications, I think. Right. Again, you know that n3 is congruent to 1 mod 3. No. Uh, the number of silo subgroups is congruent to 1 mod, yeah, correct only, right? This you know, is this result there?
No, the result. Only.
You know the result?
Yes, yes.
Okay, right. Sorry, yeah. So then it will be 3k plus 1, right? So basically, maybe no need to write that. Yeah. So our claim is to show that it is 1. Right? I might be wrong, okay, but see, claim is that n3 is 1.
N3 is the number of the silo 3 subgroup, right?
Mhm. Yes. So there is another thing about silo subgroups, another thing on the size, which is that it must divide something. Yeah, must divide something. So I think the other result is n3 should divide G modulo the normalizer of P, here it is H. Okay, and let me explain
And
this.
why it is?
Yes, yeah. Let me, because this is not the, I think this is not a part of the standard silo thing, but it's quite easy. So for this, you consider the G, the group G, acting on S, where S is the set of 3 silo subgroups. Okay, and the action is given by conjugation. Okay. So how is the action defined? Action is defined. So this is equal to G inverse Hg. Is it okay? Now, number one is, yeah.
Here we are taking S equal to the H or the only P subgroups.
3 silo subgroups. Collection of all 3 silo subgroups.
Okay, collection of all. Okay.
Yeah. Which means 3 silo means order 3 cube. Right? Order 3 cube. So if you act on that, then the action is transitive. Why? Because you know the conjugation thing. Every silo subgroup is conjugate of some silo subgroup. Given one silo subgroup, take conjugates, you get all silos. Right? That is one of the silo theorems, and that translates into showing that that fact is same as saying that the action is transitive. Means that you can get anywhere from anywhere. Okay. So what I'm just saying is that given H1 and H2, there exists a G such that G inverse H1G is H2. And this is actually the one of the silo theorems, right? Okay. So action is transitive, so you apply the orbit stabilizer formula, which basically tells you that the number of 3 silo subgroups, which is the cardinality of this set, which is N3 in our notation, that is equal to orbit stabilizer formula, that is size of the group divided by the size of the stabilizer of any particular silo subgroup. Okay. So what is stabilizer? Let us come to stabilizer of take any H. What is this? My claim is that the stabilizer is nothing but the normalizer. H is a subgroup, 3 silo subgroup. I'm computing its stabilizer with respect to this action. That is just equal to the normalizer. Just check the definition, right? Because this is just, you have to just take those G, so that G inverse Hg is equal to H. But that is what the normalizer means. That's it. So basically, so maybe I should have just written this is equal, right? Okay. And this implies that N3 divides G mod H. Because H divides the normalizer, right? Because H is a subgroup of the normalizer, of its normalizer, right? So H divides NH, right? So G mod H, the ulta ho jayega, right? And so N3 will divide this because this is equal to N. This is just calculation. So this is how I was writing initially, but
N3 divides G by H. What does it mean?
yes, you are right. Yeah, so I should put mod. Correct. I mean size of G by size of H. Yeah.
But we are taking normalizer of H, right? So why it's like just only mod of H?
That I said, no, because this thing divides this thing, right?
So normalizer have a bigger
Yes, sir.
cardinality.
Yeah, of course. Bigger, and so it will be multiple, right? Lagrange theorem.
Yes, so H is smaller, so
So size of H will divide
N3
size
can
of.
divide N of H, but why N3 will divide mod of H?
This will divide, no? Your question is this?
Yes, H divides normalizer. Yes, that's okay. But
then
as H, order of H is less than normalizer of H,
H is a subgroup.
so
H is a subgroup of normalizer of H. So size of H will divide size of normalizer of H. Right? Just think for a minute.
okay, got it.
Right.
Just because when we are taking H smaller in what the denominator,
Yeah, yeah.
so the
Divisibility. Okay. So this is the thing. And so basically from here we get that N3 is equal to 1 or 4. Right? So this implies that N3 is, so we have reduced the case, right? N3 is 1 or 4 at least. Cannot be more. Because G mod H is 4. So we need to just somehow show that it cannot be 4. Okay? That I don't know how to do. I'm trying with you. So to show N3 is not equal to 4. So we need a finer analysis. Yeah, we need to. Sorry. So this basically you see this situation doesn't usually happen. N3 is equal to 4 is equivalent to this, right? That G is equal to H is equal to NH, right? So if N3 is equal to 4, eventually it's equivalent. That implies NH is equal to H, right? That is the thing. So it basically is saying that the normalizer does not grow. So we need to get some, this kind of situation doesn't usually happen, but it happens. Self-normalizing silo subgroups exist. They don't exist in symmetric groups, but in subgroups they can exist. That fact is difficult to prove that they don't exist in symmetric. It's quite, but anyway, let's think about this. I mean, there are some more theorems I can use, but there is something called Fratini's argument, maybe that we can bring. But it should be simpler than that. H is equal to H. Those things come after we. Let me just get. Yeah, let me think for some time.
You can just say just why if n3 equal to 4, then normalizer of h equal to
Yeah,
h.
yeah, yeah. Just think. Put n3 equal to 4 in that equation. Just here you play around and see. While I'm thinking, you think.
Oh,
You see, I have taken another action. I've considered another action. Okay. I have taken this, I'm assuming it's 4. I've taken another action where I've taken this H, one particular H, and I have taken the conjugates. Sorry, cosets. Okay. I've taken the left cosets. Okay. And then you consider this action. So this action basically gives you a homomorphism from G to S4. Okay.
But S4 has
Yes, yeah.
24 elements.
It has 24 elements. Correct. It has 24 elements. But we get a homomorphism from G to S4. Do you agree with this? Right.
Not getting why it's
So that is a group action, right? So, I mean, but I'll just tell you this first intuitively. So every element of G is creating a permutation of this set. Right? That's what action means, right? Every element of G, when you act on a set X, then it gives a permutation, right? But this is just a set of size 4. So every element of G goes to a permutation, right? That is the
Yes.
alternate view of, that's the view of group action, different view of group action, same thing in the end. But fine. But maybe you have not used this before, but I'm just telling you, okay? Why it's a homomorphism and all? Yeah.
Why it's S4? I'm not getting that.
S4 because there are 4 things, no? It's permuting a set of size 4. No.
Oh, okay.
Right.
Yes, got it,
That's
got
why.
it.
And so, and now this map, now as you said, this has size 24, this has size 108. Right? Okay. So it means that this
Yes.
map cannot be injective. So it must have a kernel. You cannot have an injective
Yes,
function from, right?
Non-trivial.
Correct. Non-trivial kernel. And the kernel cannot be all of G also because this map is not trivial. That's why I said,
Yes,
I already said non-trivial. Yeah, correct.
Yes.
So it means that there is a kernel K, but kernel is normal. Kernel is a normal subgroup.
Yes.
That's it.
No, why kernel is normal subgroup?
That you prove, man. That you should prove. That's the thing. Why is kernel normal? That's group theory. Yeah. It's a basic thing. You try to prove on your own, right? Yeah. I mean, every normal subgroup is also a kernel of something, of some morphism. I can tell you, but you can think about it on your own. Okay. Why is kernel or not? Take any map from G1 to G2, kernel is always normal. Okay. Just think about it. Now let me just see if I've said something wrong, because it would not be. See here in this, if you look at this solution, it's so do 2 things. Assume the kernel is normal. We can prove everything, but now just zoom out and see. We have used the power of silo subgroups, the silo theorems also, right? Otherwise हम लोग 4 पे reduce नहीं होता, right? Okay.
Yes.
And if it was not 4, if it was some 12, then this theorem would have not been useful, because if this was 12, then you could not have said you have a non-trivial kernel. It could have been injected. I mean, S12 क्या S5 लेने से ही then you cannot say. I mean, S5 लेने से भी actually you can say by some more theorem, some easier theorems actually, but in general I'm just saying that this 4 was important, मतलब कि reduce करना important था. So we used all the power of silo subgroups there, but then we had to do another thing which I did here. which is this action again. Okay. Okay. So both the steps are there. Now you just think. You see, I did not get this in a minute. I also thought, right? I thought many other things which did not work, and then I came to this. Think about it. We can discuss more if you want about this on the other side, and if you want, then we can do some other problems. Okay, it's up to you. But you think, and after 5 minutes we can make. That is better.
Just
I'll not end the
there is
meeting.
a kernel.
Say. Yeah. Continue.
There
Please.
is a kernel, and that is not non-trivial and
Kernel is always normal.
normal. But then why n3 doesn't equal to 4? 4 क्यों नहीं होगा?
हाँ, I did not prove that. 4 हो सकता है. But I just found a normal subgroup.
अच्छा, okay.
Correct, you are right. So I did not actually this claim I did not prove. But we got a we got a normal subgroup in some other way. Okay, मतलब it's a mixture, right? ऐसा मिक्सचर क्यों होता है? बिकॉज ये 108 साइज का सब ग्रुप एक नहीं है. देयर आर मेनी सब ग्रुप्स. ओके, नॉन आइसोमॉर्फिक व्हिच आर डिफरेंट स्ट्रक्चर्स. ओके, किसी में द साइलो सब ग्रुप विल बी नॉर्मल, किसी में साइलो सब ग्रुप विल नॉट बी नॉर्मल, एंड देन द नॉर्मल सब ग्रुप कैन कम इन अ डिफरेंट वे. एंड दिस इज क्वाइट अ स्ट्रेंज वे, राइट? दिस वन you actually don't know the subgroup, but you know that there is a normal subgroup. That's group theory. That's mathematics, right? Showing that something exists without finding it. If you can find it, then you don't need mathematics to show it exists, right? Then you just need computer science. That's the thing. You don't know how that subgroup will come.
Okay, I have a solution. Can I send it to you?
Yeah, okay. Yeah. You can tell me
Send
how
to
it is
mail.
also. Okay.
Okay, it's okay. So
I don't mind reading it, but it's just the time that I'm trying to calculate. Okay.
okay, it's better if you I send you the picture because I'm not also clear about this proof.
Okay. Just send it to me then. Okay, then I'm ending it and seeing you after 5.